On your computer, everything happens on the system board. It is this main motherboard that contains all the important components for your computer. Your memory is on this device. All of your CPU cycles are cycling on this motherboard. Everything happens right here. You'll sometimes hear this referred to as the MOBO, and there are some very standard sizes of motherboards that you can use for your computer. These motherboard technologies are changing all the time. We have different chipsets in the way that these motherboards are laid out. There's different bus speeds between all of the different components, and there's even different ways to cool these motherboards. In this video, we'll look at a very high-level view of how these different motherboard components interact with each other, and we'll also see how things have changed through the years and what you can expect to see on today's modern motherboards. Here is a picture of a motherboard. There's so many different components on this device to work with. You can see slots for the CPU. There are slots for the adapter connections. There's memory connections on here, and there's a lot of other chips on the motherboard as well. What we're going to do is step through what all of these different components are and how they interconnect with each other. Here's a very high-level view of a set of motherboard chipsets. And keep in mind that this is just one example of a motherboard chipset. The motherboard you're using will probably have similar components, but they may be connected in slightly different ways. In this video, we're going to focus our conversations on the middle of this picture. We're going to look at the north bridge, which we also call the memory controller hub, and we're going to look at the south bridge, which is the input-output controller hub. Our motherboards have changed a lot through the years, but by understanding the idea behind the north bridge and the south bridge, we'll understand better how today's modern computers are designed and how we got to the point that we are now with today's chipsets. Your computer spends a lot of its time pulling information from memory, putting that information into the CPU to be executed, and then taking the results of that and putting it back into memory. There's constant communication between your CPU and the memory that's inside of your computer, and it all connects together with a central memory controller hub. We've traditionally called this the North Bridge, and it's one that has a lot of communication, very high bandwidth communication. Most modern computers that have North Bridges will even have heat sinks or fans and other ways to cool this because it's getting very, very warm sitting on your motherboard because it's working so hard. For everything else on your motherboard, there is still a central manager, and it's called the South Bridge. It manages connections like connections to your interface slots on your computer. Maybe it's connecting to other peripherals as well, USB connections, Ethernet connections, connections to hard drives. There might be onboard graphics controllers that go through your South Bridge to be able to communicate across your motherboard. Your BIOS itself may be connected to the South Bridge. This allows the South Bridge to handle all of those other input and output functions for your motherboard and leaves the North Bridge primarily responsible for getting information back and forth between the CPU and the memory. Now, all of these components are working together, but if we were to look at an actual motherboard, we should be able to look at each one of these different types of connections and figure out where it goes on the motherboard. And you should do the same with your motherboard. Grab the motherboard manual, have a look at what a picture of your motherboard might look like, and you should be able to piece out and see where each one of these components happens to be. Let's look at the motherboard we started with in this video. There's all of these different components. Right here at the top, we have CPUs. In fact, this particular motherboard has two separate CPUs that we can connect with. Now, very close to the CPU are these memory slots that are in the motherboard as well. And as we were talking before, our North Bridge is the device that connects our CPU to our memory. So it's probably not unusual that right in the middle of those is the memory controller hub or the North Bridge. Now, we have a lot of other input-output devices on this motherboard, like your PCI adapter slots. You've got a graphics controller for the motherboard, so you don't need a separate graphics interface or controller taking up an adapter slot. You've got Flash BIOS that is on here to start your computer up from the very beginning. And there's even a Super I/O, which is a single chip that handles a lot of the input and output for serial port, parallel port, floppy drives, keyboards, mouse, and any of those other tertiary components that we need to communicate with that need lower bandwidth and don't have the same requirements for throughput as other parts of the computer. We've also got in the middle of all of those the south bridge that's connecting all of these different pieces together, and it of course is connecting up to the north bridge on the other side. This is a traditional way of looking at chipsets on a motherboard, but one of the things that we've done through the years is modify this traditional view so that we can get faster and faster throughputs, and our computers can go faster than they ever have. One of the ways that we've been able to improve the speeds of our computers is to consolidate all of these different chipsets into smaller and smaller pieces. In this case, I've got a picture of an Intel Ivy Bridge CPU, and we've taken and consolidated a lot of those external functions directly into the CPU die itself. And you can see, for example, looking at this, that we have the CPU cores that are inside of the CPU. There's a shared layer 3 cache because we got a layer 1 and a layer 2 cache on each individual core. But here's where we start consolidating. When we looked at our North Bridge or our memory controller hub, it was a separate chip on that legacy motherboard. But notice here that the memory controller and the memory controller input-output are integrated into the CPU itself. This is on the Intel Ivy Bridge CPU. And in fact, the external processor for the video that was elsewhere on the motherboard has also been integrated into the CPU itself. So a lot of those external pieces that needed an extra bus and were simply going over those slower connections are now in the same piece of silicon itself. And by doing that, we can get very high speed throughputs and communicate at very high speeds to our memory without having to go through a separate North Bridge just to be able to transfer information in and out of memory.